Good morning, everyone. Yesterday, we have done something called trigonometric identity. At this point, the trigonometry is formulas. Unless you digest all the formulas, there is no point we continue with the exercise. So I have given you all a first formula here: sine squared theta plus cos squared theta is equal to 1. Look, from this one formula, I can make so much formula. Look, let me erase most of this. Let me do it on the side. Yeah, ignore this. So we have got one formula right here. We have got sine squared theta plus cos squared theta is equal to 1. I can make a formula like this. I am taking the cos squared theta to the right hand side. So we have got another formula, and if I want to find out sine theta only, the square will go to the other side. It will become root over 1 minus cos squared theta. So from this single formula, I can obtain two more formulas. I can obtain two more. We have taken away the cos squared theta to the right hand side. What if I take sine squared theta to the right hand side? Now that will look like this. Let me write with another color. If I take away sine squared theta, this part right here to the right hand side, what is remaining on the left hand side is cos squared theta. So we will have 1 minus sine squared theta. And if I want cos theta, we will have root over 1 minus sine squared theta. Look, from this single formula, I can obtain 1, 2, 3, 4. You don't need to remember this form. This is the mother formula, right? This is the formula that you need to absolutely remember. I will write two more formulas which is similar to this, not just for sine and cos, but there will be formulas that connects tan and sec, cosec and cot, those things. We will try to derive it right now. You don't try to remember this part. You don't try to remember how we have arrived this sine squared theta plus cos squared theta equal to 1. You just need to understand, okay? And you need to remember sine squared theta plus cos squared theta equal to 1. When you do revision for the exam, ignore this part, not necessary. What you have to remember is you focus on this part right here, sine squared theta plus cos squared theta. Okay, now I'm rubbing this part off. This part, I'm rubbing this off. And we will try to obtain another formula, okay? We divided both sides by AC square yesterday. Now I am going to divide it with another one. I'm going to divide it with, we have divided with AC, right? Now we will divide with AB. And for the other formula, we will divide both sides with BC. So we will divide, this is the Pythagoras theorem from this right angle triangle. Now, dividing both sides by, we have done division with AC square, move on to AB, you divide with AB square on both sides. Dividing both sides by AB square, let's see what we will obtain. Okay, one moment. My screen is a little wet, that's why it's breaking up. Okay. We're going to divide both sides by AB square. Now you have to divide this term with AB square, this term with AB square, this term with AB square. Okay, now let's divide. So what we are supposed to obtain? We will obtain AB square by AB square, BC square by AB square, AC square by AB square. All right, now look, the similar ones, let's cancel them out. AB square and AB square can be cancelled. What is remaining? If I cancel these two out, this is just division cancelling me. That means we will have one remaining here, one remaining here, 1 by 1, which will obviously be 1. So if I continue on the right hand part here, we will have 1 plus, I'm writing the square together like this. Same thing for the right hand side. Now let's write them in terms of opposite, adjacent, hypotenuse. So 1 plus, what is BC? Look, if you look from the figure, BC is the adjacent, AC is the hypotenuse, AB is the opposite. So just write them down. BC is adjacent by AB is what? Opposite. Whole square is equal to AC by AB. What is AC? AC is hypotenuse divided by AB is what? AB is opposite. Whole square. Okay, now you can look up to the trigonometric ratios that we have given in the beginning. Adjacent by opposite. What is it? We know opposite by adjacent, right? We know opposite by adjacent. Some of our children are having trouble over algebra. This is trouble over algebra, opposite and adjacent. This is T, so this formula must be tan theta. But it is not opposite by adjacent here. It is adjacent by opposite. What is adjacent by opposite? Adjacent by opposite is the reciprocal of tan theta. What's the reciprocal of tan theta? We will obtain this as cot theta. So this part here, we will replace it as cot. What about hypotenuse by opposite? You know opposite by hypotenuse, right? Sin theta is equal to opposite by hypotenuse. But if we have hypotenuse by opposite, it will be the reciprocal of sin theta, which is cosec theta. Okay, this is cosec. I'm just mentioning the part inside the bracket. We will put the square later on. Adjacent by opposite, we will replace it as cot theta. Hypotenuse by opposite, we will replace it as cosec theta. Then write it down. What do we get? Look, 1 plus. This is cot theta. Where do we write the square? I just told you all yesterday. You cannot write the square here. You have to write square in the middle. So adjacent by opposite, we will write 1 plus cot square theta. What about hypotenuse by opposite? This is cosec theta, right? And we have to write square here in the middle because there is a square outside the bracket. So this is another formula, but we don't write it this way. Most of the time, 1 plus cot square theta is equal to cosec square theta. We don't write it this way. How do we write this? We write this in another way. If I take the cot square theta to the other side, then it will become minus. The plus will turn into negative sign, right? So we will have 1 is equal to cosec square theta minus cot square theta. Let's change the sign. Cosec square theta minus cot square theta is equal to 1. I can rub this off. The middle one, we don't use it very frequently. So we have got another formula. After we obtain sine square theta plus cos square theta is 1, we have obtained another formula. Cosec square theta is minus cot square theta is equal to what? 1. There will be one more formula. We have divided from this Pythagoras theorem. We have divided both sides by AC yesterday. Now we have divided with AB square again, right? And we will divide it by BC square in the next one. Then we will obtain another formula that will have tan theta and the sec theta in. Okay, so you copy from, ignore this part. We have already done this yesterday. You write Roman number 2 here. You write Roman number 2 here, and then you copy this. You copy this part. Okay, don't copy up to here. This part we have already done yesterday. Copy this part. No need to draw the triangle also. We have already drawn it yesterday. From 2, copy from here until here. Quickly, someone just tell me when you all are done. Okay, let's take 2 or 3 minutes. Don't take more than. Is it done? Let's make a topic into identities. Not just identity. Okay, this is supposed to be plural.
Sir, done.
Done. Okay, now I'm rubbing this part off again. Let's come to formula number 3. Okay, so formula number 3, we are not going to divide by AB square. We have divided with AC, AB. Now we will divide by BC. We will obtain a new formula. Let's see what it is. Now we will divide by BC square. All right, so we will still use this equation. I have to divide this part by BC square, this part by BC square, this part also by BC square. So the result will be AB square by BC square, BC square by BC square, AC square by BC square. As usual, I can cancel out the two of them, the similar one. So what is left? Let's put it. Now we have AB by BC. I'm putting the square outside. plus BC square and BC square got cancelled. One must be remaining. And there is AC by BC whole square. And remember, AB is the opposite, BC is the adjacent, AC is the hypotenuse. So what is the result here? We are obtaining AB is opposite. I'm writing opposite by BC is adjacent. Opposite by adjacent square plus 1 is equal to AC is hypotenuse by BC is what? Adjacent. So opposite by adjacent square plus 1 is equal to hypotenuse by adjacent square. Look, opposite by adjacent, this is tan theta. Okay, again, when you come for trigonometry class, write the formulas in a piece of paper and bring it from tomorrow without fail. Write all the formulas on a piece of paper. That's for easier to remember. Okay, I will teach the concepts, I will teach the question, but if you don't practice, it will be like thin air, it will just fly away. So keep the formula in front of you so that you will understand what formula I can apply this, what is this adjacent by opposite. In case you don't understand them, trigonometry, it will turn your heads around so much. So opposite by adjacent, this will be tan theta, and the square we will keep it in the middle, plus 1 is equal to hypotenuse by adjacent. Remember, adjacent by hypotenuse is cos theta. Reciprocal of cos theta, we will have sec theta. So there will be a square here. And this is the other formula. All right. So we have got 3 so far, and this is Roma number 3. You can remember this formula in another way. I can take the tan square theta to the other side. So we will have 1 is equal to sec square theta minus tan square theta. The tan square theta is brought on the right hand side. Change sides, we will have sec square theta minus tan square theta is equal to 1. Now we have got another formula, and remember we want 1 on the right hand sides on all of them. Sine square theta plus cos square theta is equal to 1. Remember, like this, there is 1 on the right hand side, and cosec square theta minus cot square theta, the formula that we have just done. This is equal to 1, and we have got sec square theta minus tan square theta is equal to 1. So these 3 formulas, these are very important, okay, for calculating your exercise 10.2. There is a big question there. I think question number 4 or something. I forgot. Actually, question number 11. Question number 11, there will be a 3-mark question from there without fail in your board exam. If you don't understand these 3 questions, then there is no point. Okay, you write them down from tomorrow onwards. Today, it's fine because we have just finished I've just finished giving you all the formulas. And once these are done, you have to write down all the formulas in one sheet. Okay. Now copy up to here and just tell when you all are finished. We will take up questions from the exercise now. And no need to copy from here again. I'm reminding you all, this part is done already yesterday. You have to copy from here, Roma number 3. Make it quick, don't take very long.
Sir, done.
Done. Okay. Okay, now let me list out the formulas that I have given so far. I'm removing this. So the formulas that I have given so far, this we have got sine theta is equal to opposite by hypotenuse. I'm just writing the letters, okay? Cos theta is equal to adjacent by hypotenuse, and tan theta, this is opposite by adjacent. And you can write the other remaining 3 as reciprocals. Like for sine, that will be cosec theta. So we will write hypotenuse by opposite. For cos theta, you have to write sec theta. This is hypotenuse by adjacent. And for cot theta, we will write adjacent by opposite. That's the first 6 that you need to remember. And as I've told you all, you need to remember these 3 only. The others, you can just remember it as the reciprocal. And the relationship between these trigonometric ratios 1, 2, 3, 4, 5, 6. Cosec theta, that is the reciprocal of sine, so we write 1 by sine theta. Sec theta, we write it as 1 by cos theta. And cot theta, we write it as 1 by tan theta. This is the next three, okay? So some more formulas. Tan theta, what was the formula that we have obtained? We have obtained sine theta by cos theta. And cot theta, we will write this as cos theta by sine theta. And the three extras that I have just given right now from yesterday, sine square theta plus cos square theta, this is equal to 1. And cosec square theta minus cot square theta, that was also equal to 1. And sec square theta minus tan square theta, this is also equal to 1. These three are called identities. Why are they called identities? Because these formulas, they remain true. This relation remain true whenever you put the value of theta as any angle. If you put 30, if you put 30 degree here, the formula will be true. If you put 90 here, the formula will be true. Okay, whatever angle that you put there, these three formula, they will remain the true. That's why they are called as identity. So you need to remember six. Out of six, you need to remember only these three. The others, it will automatically come by yourself. It will come by itself. And which are the reciprocal of which? You need to remember that. This will be very easy, okay? And this one, these are very important formulas. Just simple one. Tan theta is sine theta by cos theta. If tan changes into cos, you turn it upside down. Okay, sine theta comes down, cos theta comes up. So tan theta is sine by cos, cot is cos by sine. And these three, try to remember it by yourself. You practice it daily, okay? Until trigonometry is done, you try to practice the formulas daily. And if you don't understand, if you don't remember the formula, no point. As I've been saying. Okay, let's take up questions from your exercise 10.2. I'm taking up the first question. I'm not writing the whole question here. And also, I'm taking up from question number one, I'm taking up just the Roman number one. The Roman number one is sine A cos A. Okay, if you read the question, it says in a right triangle ABC. I think you have, you all have the textbook right there, isn't it? So, uh, can anyone turn off the microphone? You turn it on when you have the question. Okay. So we have got here. Look at question number one. I'm just doing one question, one Roman numeral out of the two. Question says in a right angle triangle ABC, right angle, let's see. I'm writing here. Right angle, let's see. The value of AC is 3 centimeter. The value of AB is 5. What does the question want? Find the value of sine A and cos A. You might wonder why there is no theta here. If I have a triangle ABC, and if I'm taking this angle, then we will write the trigonometric ratios as sine A, cos A, tan A, cot A in this way. No need to write theta here, okay? It can be replaced with the letters that you are using. If I take this angle C right here, this is A, B, C. If I take this angle, this is angle C. So we will write sine C, cos C, tan C, like that. Okay, so let's draw the triangle. It is supposed to be right angle. Let's see. So first of all, you draw a right angle triangle. Right angle, let's see. So this part is fixed. The others two, you can write randomly. You can write any vertex that you want, any letter that you want. Question wants what? The question wants, according to Roman number one, it wants sine A cos A. So which of these two angles is the question taking? It is taking the angle A, right? So we're taking this angle according to the question. Based on this angle, what is the opposite? This is the opposite. So BC is opposite. I'm labeling it. And the next door, the next side, the side that is next to this angle itself, that will be the adjacent, right? Now we know adjacent, we know opposite. The hypotenuse is supposed to be fixed, but let's write it anyway. What is sine? What is the formula of sine? Now sine A is equal to, what's the formula? The formula is for sine its opposite by hypotenuse. Sum of her, right? SOH. So opposite is which one? It's BC. I'm writing it as BC even if it's CB, okay? Yeah, CB, BC, same thing. And hypotenuse is what? Hypotenuse is A. There is one issue here. AC is given. The value of AC is given, which is 3 centimeter. Value of AB is given to be 5 centimeter. This is given as 5. This is given as. So we don't know this one, right? We don't know what is BC. We don't know this part, right? How to find this out? We have to use Pythagoras theorem. So before we come to finding out sine A, cos A, now first of all, we need to find the BC by using Pythagoras theorem. So say here, by Pythagoras theorem, write Pythagoras theorem, it is AB square equal to AC square plus BC square. Hypotenuse square is equal to sum of the right side square. Whatever value we want to calculate, which one is it? AC we have, AB we have, we don't have BC. So find out BC, that means AC square has to go to the other side. So AB square minus AC square is equal to BC square. Let's put in the values. AB is 5, right? 5 square. AC is how much? 3. 5 square is 25 minus 9. So let's change the side. We have got 16, which is 4 square. Now you can cancel the square from both sides. Remaining, we will have BC is equal to 4 centimeter. Now we have all the sides. We have got AB and AC given, and we have found out BC. So hypotenuse AB, it's 5 centimeter. And what about the adjacent? It's 3. And what about the opposite? It's 4. Now, since we have found out all the sides, we can focus on what's the value of sine A. The value of sine A is opposite by adjacent, so that will be BC by AB. Put in the values, 4 by 5. Cos A, it's AC by AB. Adjacent by hypotenuse, right? So we have got 3 by 5. That's it. Very easy one. If I change to angle B, then opposite will be this one, adjacent. So you just have to change the opposite and adjacent. If instead of sine A, cos A, if the question asks sine B or tan B, then you have to change the sides first, which is adjacent and which is opposite. Come to question number 3. Okay, question number 2, you can try it out. I'm not giving you assignment. You can try it out. It's not very difficult also. And question number 3, I'm going to calculate based on this. You are supposed to do, let's say you are do question number 4 and question number 6. Question number 6 here. Try to do this question number 4 and 6 as an assignment for this week. Okay, when you submit the notebook, you bring them as your home assignment. Now let's see. We are not given any triangle. We are just given the value of cos A as 3 by 5. And what are we supposed to calculate? We are supposed to calculate sine A and tan. Okay, now even if the question doesn't give you a triangle, you imagine a right angle triangle. Always a right angle triangle in case of trigonometry, okay, at your level. Now the just this is A, so don't make the A as the right angle. The others make right angle for B and C. You can put C here or B here, it's your choice. But don't put A as the right angle because we have to calculate cos for angle. Now, this is the angle that we are taking. This is the angle. And based on this angle, we have got the opposite right here. This is the opposite. And this is the adjacent, right? So, I'm labeling them opposite, adjacent. And this is the hypotenuse. Now, let's come to the solution. What we have is cos A is equal to 3 by 5. What's the formula for cos A? The formula for cos A is adjacent by hypotenuse, right? So let's replace it according to the triangle. Instead of writing cos A, I'm going to replace it as cos is adjacent by hypotenuse. So we will replace it with AB by AC. All right. So it will be replaced with AB divided by AC according to the triangle that we are drawing. Okay, now we have got a ratio AB by AC is equal to 3 by 5. AB is equal to suppose 3A, AC is equal to 5. Then what will be the value of AB by AC? It will be 3A by 5A. To cancel the a and a, we will got 3 by 5, right? So since this is given in terms of ratio, you can take AB as 3 something, 3 multiply with a constant. And AC also, you will have to take it as 5 multiply with a constant. So from here, we can take out two values. We can take out the value of AB is equal to 3K. I'm writing K, okay, constant K. And what about AC? The AC will be 5K. If you use K here, you use K here. If you use A here, or you use A here. Either letter, any of the letters is fine. Now we have got AB is how much? It's 3K. The length of AB is 3K. So let's write it inside bracket. And AC, the hypotenuse, it is 5K. So 3K here, 5K here. One side is missing, isn't it? So similar to the previous question that, similar to the method that we have done for question number 1, you do Pythagoras theorem here. By Pythagoras theorem, I'm doing it a little quicker. See if you follow. If you don't understand, just ask. Okay. AC square is equal to AB square plus BC square. We are supposed to find out BC because we don't know the value of BC. BC square will be AC square minus AB square. AC square will be, I will replace it with 5K square. AB will be replaced as 3K square. Just putting the value, simple. This we have right here and right here. Now square it. 5 square is 25K square. 3 square is 9K square. The square will be 4K also, right? Isn't? So there is a square on the K also. Subtract them, we have got 16K square. 16K square, I can write it as 4K whole square. What is in the right hand side, left hand side? BC square. So square and square can be cancelled out. What is the final value of BC? BC is 4. That means the opposite of angle A is 4. Now we have got all the sides. Hypotenuse and adjacent, we have obtained it from the value of cos. Because cos A is adjacent by hypotenuse. Now AB, we don't take 3, just 3. We have to take with a constant also because this is given in ratio. And AC, we have taken it as 5, and we have to have a constant also. And now, after obtaining AB and AC, we have obtained three sides. We have two sides. The third side we have found it out. And now you can calculate sine A and tan. You may have a question, is the opposite and adjacent fixed? Yes, if you take angle A. If you take just this angle, opposite is fixed, adjacent is fixed. You cannot change the opposite and adjacent. If I take another angle, this C, then opposite will be this one, adjacent will be this one. They will interchange. Opposite and adjacent, they will change. But if you take angle A only, opposite will be here, adjacent will be. Now, according to the question, we want sine A and tan A. Okay, let's find it out. Very simple. Sine A, how do we find it out? This will be opposite by adjacent. So opposite is what? BC. Sorry, opposite, not opposite by adjacent, opposite by hypotenuse, right? Opposite by hypotenuse is what? AC. Put in the values. BC is 4K, AC is 5K. K and the K can be cancelled out, so we have got 4 by. What about the 10A? According to the question, the formula for 10A is opposite by adjacent, right? Opposite is what? Opposite is BC. Adjacent is what? AB. Put in the values. So we have got 4K divided by 3K. Cancel the K and K, so we have got 4 by 3. So look, the method is very simple. Cos A is given as a value. Now we draw a right angle triangle. And since it says angle A, we don't make the angle A as right angle. You cannot put angle A here as 90 degrees. That will be wrong. You put the angle A here, the vertex A, you have to put it here or here in either of these 2 points. And then we express it according to the question. Since angle A is fixed here, this is opposite, this is adjacent. And the formula for cos is adjacent divided by hypotenuse, and we obtain it. And we separate the value. We have just obtained 2 of the sides. The third side, we find it out by Pythagoras theorem. Okay. And if we found out all the 3 sides, it is very easy to find out any of the trigonometric ratios. Whether you want sec, cosec, cot, or sine, tan, any of the ratios you want, you can find it out. Okay, copy this. In case you don't understand, just ask. Okay, this is still in the basic stage. This is in the beginning stage. If you don't digest here properly, then big issue. Okay, then let's finish for today.